Hello guys, welcome back to Next Gen Coders, and today we will be reviewing Unit 1 of AP Computer Science A. We will just be going through each of the lessons and talking about them. So first is Lesson 1, and it's basically about output in Java and strings. A string means anything that is not used for numerical calculations, and this can contain any kind of characters such as letters, numbers, or symbols. So for example, a string can be a dollar sign, a lowercase a, any number, an uppercase a, and this can be a line of characters or just one, depending on the length. And whenever we declare a string, we do need to include a double quotation marks. And this is just a rule in Java because if you don't include it, it'll create an error and it won't output correctly. How we output strings is that we use system.print or system.print ln. And in those parentheses, we write our variable or our specific thing we're going to say. The difference between system.print and system.println is that when we use ln, a new line will be printed the next time. Now, it's important to remember next time because the new line will be executed the next time we print a statement. Another thing to remember is to always end with a semicolon whenever we declare or output. So in the next slide, I have an example here. So the first statement shows how we declare a variable, and in this case, a string. So we start with a capital S, and every time we declare strings, we do that. So string A equals quotation marks hello. So these quotation marks define the variable, and we end with a semicolon to execute the line. And the next example here is we see how to print the string. So we just have hello right here because when we go back, we can see that variable A means hello. We can also see that Emma is placed in quotation marks because it is not a variable. It's a statement that we added. So for the next lesson, we have user input and variables. In this lesson, we will talk about how we can utilize user input in our code. And so the first line shows the statement we will need to use, and it is scanner scan equals new scanner system.in. And this line basically goes at the beginning of our code, and it allows us to use user input in our output or execution. Variables are basically containers in memory. An example is string n, which equals hi in quotation marks, and also int n, which equals 5. And you can see how we don't have quotation marks for integer or other data types. Variables just make it easier for us because instead of writing the same thing over and over again, we can just use that and call that data whenever we need. Some naming rules we have are that we can use letters, numbers, underscores, or symbols, but we can't use any spaces or we can't start with numbers. So for example, if I wanted to name mine the title, I couldn't use a space in between them. Instead, I would replace that with a dash or an underscore. So now it would be the underscore title. Now we can use numbers, but they can't be at the beginning of the name. So instead of one apple, I could say apple 1. The next part is printing strings, and we went over this before too, but basically combine the strings and variables with the addition symbol, plus an example you can see below is hello plus n plus how are you. So this just helps print the name and the introduction. And also for comments, you just use 2 backslashes and then the one you want to write. And these are just useful for if you have a team working or you just want to know what that piece of code does. We can see right here that I have an example of how user input is incorporated. So first we have scanner scan equals new scanner system.in, and this is just a basic line. And then next we have a question that is asked to the user. And basically when the user responds to this, the string n equals scan.nextLine stores this information into the n variable. And so when we print out hello plus N plus how are you, the output is hello, Emma, how are you, if the user inputs Emma. So the next lesson is data types, and these are just the different data types that we can use to declare a variable. So the first are primitive data types, and these are integer, int, which are whole numbers like 5, 4, 3. And the next one is double, and these are decimal numbers like 4.2. And these can also include like 4.0. And these are used when we have a decimal amount or we have a decimal at the end. The next is Boolean variable, and this is just a true or a false. So, for example, if there's an if statement, which we'll learn later, and it's true, it'll come back as true, and then if it's false, it'll come back as false. And the next data types are reference types, and this is string. And this is basically text data, and it takes more memory as it stores each character. And this can be like a line of characters. There's also scanner input, and we went over this already, but one thing that I haven't said before is that for each one, when we use the scanner method, we need to make sure that we're matching the data type. So for example, for int x, we will have to use next int, and then if we use a double, we'll have to use scan.nextDouble. So input mismatch can also happen if the input type doesn't match. So if you store cat in the data type for integer, it won't match and it'll cause an error. So there are literals and variables, and literals are fixed variables or fixed values like 4 or 5.3, and you can mix variables and literals in calculations. We also have maximum and minimum values. So integer dot max value and then integer dot min value shows the largest and smallest integer values. So for example, if we have an array list or just a normal list and we use this method, we can find the lowest value and the highest value. Adding 1 to the max value also causes an overflow, which can result in the wrong output. And lastly, we have final values, and these are for constant variables that we won't change. So usually if we have a variable and we can change it throughout the program, we won't use this, but if we know the variable is going to stay constant and consistent, we can use final. Next, lesson 4 is number calculations. So whenever we want to just calculate in a program, this can be based on user input or just ourselves. We use the plus sign, minus sign, times sign, and the dividing sign. And the equal operator assigns the result of a calculation to a variable. One thing we can keep in mind is that Java follows the standard order of operations. So if we do 5 plus 5 times 4, it'll first do 5 times 4, and then the result of that, it'll add 5. Integer division is a bit more complicated because if you do divide two integers, like for example 9 divided by 2, it'll result in 4. Even though the actual answer is 4.5, it'll pretend the decimal doesn't exist because integers don't store decimals. Now, if you did do the same thing but apply to cast, which we'll talk about later, it'll stay as 4.5. Also, dividing by 0 causes an error. Compound assignment operators combine arithmetic operators with equals to update variables. So for example, we can say x plus equals 2, which adds 2 to x, or x times equals 3, which multiplies x by 3. And this can be done with any amount and any operator. And whenever we want to add or subtract with Java, we just use the variable name and then plus plus or minus minus. And we have to make sure we don't only say it once, we have to say it twice. And then lesson 5 is modular division. And how we use modular division, we use the percent operator, which finds the remainder of a division. So for example, we have 7% 2 or 7 mod 2, which equals 1. Since 7 divided by 2 the closest one would be 3 times 2, which equals 6, and then the remainder would be 1. So this is useful for determining even or odd numbers, because if you do the variable or user input mod 2 and it equals 0, the number is even. Otherwise, it's odd. So for example, if we do 7 mod 2, it equals 1. So it doesn't equal 0, so we know that number is odd. And this can be useful when we have a variable that we don't know the number yet, or user input. Modular division works even if the first number is smaller. So this would just mean that the number that came first would be the result. So for example, we have a problem here. So 2 mod 9 would result in 2. In the same way, 3 mod 7 would result in 3. There are also compound modulus operators, which means percent equals, like plus equals and minus equals, and they combine percent or mod with equals to update a variable. So in the same way we did x plus equals 1, we can do x percent equals 1. So if we replace them with numbers and y equals 2 and z equals 3, it would be 2% equals 3, and that would just equal 2 equals 2% 3. And in special cases, dividing by 0 causes a runtime error, and we've already stated this before. It's an arithmetic exception. And the result of mod or percent can never be greater than or equal to the second number. So 10% 5, it can't be greater than the second number. So 10% 5 would be 0, since 10 divided by 5 doesn't have a remainder. And lastly, lesson 6 is numeric cast. So this is what I mentioned earlier. Casting converts one data type to another for a temporary amount of time. And this is usually used when we're printing or when we're declaring variables a second time. So for example, if we have int x equals 9 and then int y equals 2, and then we have double z, and this basically casts integer to make the output a double. So right here we basically are doing 9 divided by 2, but originally if we didn't cast, we would have 4, since it doesn't count the 0.5. But now that we casted it right before, and when we print z, the output would be 4.5. We also have conversions, narrowing and widening. And basically a widening conversions moves a smaller data type into a larger one. This means no errors occurs because it's basically taking your information and putting it into a larger one. So no data is lost. So for example, casting an integer as a double. Now, a narrowing conversion means you're moving a larger data type into a smaller one. So, for example, a double into an int. And this requires explicit casting or a lossy conversion, which means a loss of data will occur. So, for example, int y, and then we cast an integer into a double, we will lose that 0.5 since we're moving to a larger data type into a smaller one, which means we'll have a loss of data. And we also have something called truncation, which converts the double into an integer by discarding the decimal part. So when we have a double with a decimal point and we're converting to an integer or casting to an integer, it'll automatically lose that decimal point. So this just means truncation. And then when we're also rounding positive doubles, we need to make sure to add 0.5 before casting to integer so that we get a correct output. So for example, if we have the double as 2.8, we cast integer and then we also add 0.5, we'll get a rounded version. And that's the end of Unit 1 review for AP Comp Sci A. I hope you guys learned from this video. Stay tuned for Unit 2 review for AP Comp Sci A.